inside of a triangle have to add up to equal? 180. Okay. You've known that forever. Okay. You've known that forever. So we know that the sum of the interior angles of a triangle is 180. That doesn't change for us. I know I showed you guys earlier that if you put a triangle on a sphere, you could have more degrees, but for us, we're talking about flat surfaces. So we know that the sum of the angles in a triangle is always 180. We don't really worry about classifying them. We don't really say, hey, this one's scalene, this one's acute, this one's obtuse. I know you know how to do all those. It's things that you guys have learned 5th, 6th grade, things like that. One of the things, though, that we haven't quite talked about was something called an exterior angle. And here's what it looks like. SMRT. An angle in the exterior is the angle on the outside. Make sense? It's exterior. So interior angles and exterior angles create what? Does it matter? And here's the thing, if you wanted to create a line, if this angle inside here, let's make it easy, is 50, what's the outside angle? It's 130, very good. So it'd be 130. Now, what if I drew that outside angle here? What would it be? 130. So it doesn't matter. That's a great question. It really doesn't matter where you place it. All I'm doing is I'm looking at you have an interior and an exterior angle. Interior and exterior angles for basically all polygons as we get going into them, they're always going to be supplementary to one another. And remember what supplementary means? It means they add to 180. They create a line. They are a linear pair. A lot of little vocab stuff. Now, excuse me. One of the things that we've kind of talked about, but I don't think we've ever really shown, if you will. If I do this, and if I label my three angles as A, B, and C, what do those three angles on the inside have to add to? 180. Okay. Now, if I pick an exterior angle, let's say this one out here, I'm just going to erase the other ones. If I call this exterior angle here F, I want you to see, what do you know about angles A and angle F? What do they have? What do they create? A line. Good. If they create a line, what do they have to add up to equal? 180. So what we have here is we can create what's called a, do you guys remember the thing called system of equations? You do. X plus y is 4, 2x plus 3y is 6. Solve for x and y. Finding where two lines intersect, that kind of thing. System of equations. You did it. If you took algebra 1, you had to think. You had to see. Now, bear with me for a second. Is it okay if I don't put the angle symbol here so it just keeps it clean? You guys okay? If I just say angle A, angle B, but I'm just going to write A. We know that A plus B plus C has to equal how much? 180. What else do I know it has to add up to 180? A and F. Okay. Now, do those two equations equal the same numerical value? Yeah. You guys ever hear something called substitution? Okay. When something equals something, you put it in for something else. So by knowing that these two values are the same, I can then say that A plus B plus C has to equal, yeah. What do they have that's the same on both sides? So what would you do? Subtract it. If I subtract it, it drops out, doesn't it? That means that angle B plus C has to equal angle F. that tells you that the outside angle has to equal the sum of the two it doesn't touch. You see that? This outside angle equals the sum of the two it doesn't touch. And it doesn't matter where you place that. It doesn't matter. The outside angle will always equal the sum of the two it doesn't touch. I think that's the easiest way that to write that out. That exterior angle, the angle on the outside, the exterior angle, always equals the sum of the two angles it does not touch. Okay? So if you have an outside angle, it equals the two it doesn't touch. That's what that means. The easiest way to write that, instead of trying to get into all the technical terms of the exterior angle equals the sum of the two remote interior angles on the triangle. Who cares? It doesn't touch those two. Add those two together, it equals the angle on the outside. Easiest way to do it. Okay? Not terrible. And you're what do you like? Wait for like to get bad or something? So far.
Yeah.
It's usually how it happens, right? Yeah, Murphy set us up. It's like, it'll be all so easy, and all of a sudden, boom. Okay. Again, as I've said, what will happen is we're going to have diagrams. We have to find missing angles, which means you can do this many, many different ways. What do all the angles in a triangle always add up to equal? 180. If you have an angle on the outside, what does it always equal? No. Sum it to it doesn't touch. So you get a bunch of that stuff to work with. So take a second, draw that out, and there's multiple ways for us to figure out what those missing angles are. It's just a matter of picking a spot and figuring out what you want to do. Knowing that every triangle always adds to 180. Knowing that if you have an angle on the outside, it's always equal to the sum of the two it doesn't touch on the inside of the triangle. And from there. So you'll see that, like I said before, the math that we have, adding and subtracting here, is really easy. You just got to visualize it in the picture. You're not buying it. You wouldn't. Being pessimistic. You're welcome. Okay. What angle do you think is the easiest to find first? X. Why do you say that? Yeah. I don't know if you guys heard. If you start here at X, that's got to be 180. Subtract 43. Subtract 59. So press a couple buttons. What do you get? 68. Okay. If you do that, you get 68 for X. Okay. Now, what's the relation between X and Y? They have to add up to 180. So, what's 180? Subtract the 68. 12. And then what would you do to find the C? Yes. Exactly. Yes, sir. It's okay. She said it with such conviction, I bought it. And as you said 112, I'm like, wait, I thought it was something different like a couple hours ago. I might be wrong too. You should probably double check it. Thank you for checking that. But you were on the right track. You said what to do, and we just go from there. What? Too late. Anyway, so now that we've matched correctly, what do you do for Z? And what do you get? 151, so be what, 29? Check if I'm mathing right. Again, it's the idea that you pick a spot and just go. Okay, just pick a spot and go. I don't know, it's exhausting. Oh, that's exhausting too. All right, let's try another one like that. Way too much PDF files. But it's not, I mean, you're right, so with variables, we're going to have equations and stuff, but do you think it's really going to be that difficult? Ye of little faith. What's that? But it tells you how many degrees that gap is, doesn't it? Why can't you? There's no gap. There's two, oops. Yeah, no, there's two triangles, but the wedge here tells you how many degrees are there. Do you have to, what, do I need to know those top angles? Why? No, it's not, I'm not trying to figure out anything up here. Angles 1, 2, and 3. The wedge matters, guys, the wedge matters because look at angles 1 and 2. Angles 1 plus the angle 45 degrees plus angle 2 create a line. So all three of those angles have to add up to equal what? 180. So that's how you're able to get from starting here in the triangle on the left. You kind of have to start here. 45 and 65 gets you 110. How many degrees are left then for angle 1? 70. Okay. Now from here to here is a line, isn't it? Those three angles have to add up to equal 180. So what's 70 plus 45? It's 115. Means how many degrees are left then to get you to angle 2? Well, so the wedge is important. It's just telling you how to get into the next triangle. Okay? You're not worried about the other top two because it had no bearing on the problem. Okay? Because now you've got two angles out of 3 in a triangle. Which means, what do I have to do to find out angle 3? Yep, add them and subtract. So what's 180 subtract 85? 95. That gets you to 95 for angle 3. What I'm trying to show you guys is that it doesn't necessarily have to be just one triangle. It could be multiple triangles that you can work yourself through. It's understanding how you can get from using those linear pairs or using all 3 angles to get into to create a line. Things like that. Right? Another thing that this textbook likes to use a lot is the word ratios. I think we did some of these before where you had angles that were in the ratio. Remember?
We did that?
We might have. I don't remember. So let's say you have this. 3 angles. The angles in a triangle are in the ratio of 2 to 3 to 4. Find each angle. This textbook likes to use ratios a lot. They use it for just about, for most things. You can say the ratio of two angles that are complementary or something. The ratio of two angles that are supplementary have something. Remember what the word ratio means. If you're talking about the three angles that have a common ratio, that means that all three of those angles have some common multiplier. We don't know what that multiplier is. We need to figure that out. So when you don't know what something is, what do you usually assign to it? A variable. Good, an x. Yeah, we give it a variable. Now, when you have this ratio, sometimes they call it an extended ratio. It just means they're in this ratio. If it says 2 to 3 to 4, that just means it's 2x, 3x, 4x. So what do those three angles have to add up to equal? 180. Anytime that you see angles are in a ratio, when you see something like this with the word ratio, and you're trying to figure out angles in a triangle, all you have to do is this. You're adding them up to figure out what to get to 180. Because you're dealing with a triangle. What's that? What's 2 plus 3 plus 4? 9. Oh. Yes, 2 plus 3 plus 4 is 9. Way to go. What do you do to solve for x? Divide. What do you get? Good. The common ratio between the three angles was 20. But in order to figure out what each angle itself measures, well, 2 times 20, 3 times 20, and 4 times 20. And hopefully you're right. When you add them together, you get 180. Last time I checked, 40, 60, and 80 is? Yeah. I wasn't. So just remember, anytime you see the thing with ratio, more often than not, they're talking about just some common multiplier. And it's just a matter of using some vocab, whether it's supplementary, complementary, something along those lines. And that's what it looks like. Okay. Not terrible? Still? You're still buying in here that it's not as crazy as you guys are. Well, this is crazy until you say it's hard. It's usually what happens. What's that? What was that? What were you wondering about? Okay. All right, back to the, oops, wrong one. Back to the exterior angles. If I wanted to figure out what angle 1 is, and then I want to figure out what angle 2 is, do you think you can figure that out? Okay, take a second to figure that out. Remember the rules here. Yes, ma'am. What's that? Yeah. So what's angle 1? Oh, you're right. No, I know. And I'll throw some variables in here. Don't worry. Throw some variables. It'll be okay. I know you can say no, but I wouldn't. I appreciate the please and thank yous and stuff. The politeness is great, but I would be doing you such a disservice of trying to find X, because sometimes it's fun. I know. Not really. But I try to. But you kind of do. Yeah. So What do you do for angle 1? Yes. Right. Angle 1 is an outside angle. It's an exterior angle. This angle will always equal the sum of the two it doesn't touch, which means angle 1 is 98. Same deal. 124 is an outside angle, which means it has to add up, it has to equal the sum of the two it doesn't touch. So 124 is 59 plus something. Oops. I'm going to use an x instead of a 2 because I might add it wrong. Okay. So if we subtract 59 from 124, what do you get? How much? 65. There you go. Okay. That's what you're looking at doing here, guys. You're using the idea that the outside angle is equal to the sum of the two it doesn't touch. And it always works. It even works when there's variables. That's right. I said it. I know. Hold your applause.
How about that Bears game last night? That was very fun. It was not.
Apologize for this, the lines going down there. It just happens sometimes. Good. All right, try it out. I know this is not like really brain rat. Oh yeah. Okay, obviously this is pretty simple. So we know that x plus 80 has to equal 3x minus 22. Does it matter which gets written down first? Nope. You got variables on both sides of the equation. Pick on the little guy, so I'll move the x. At the same time, I'm going to add 22 because might as well. So we get 102 is 2x, which makes x 51. Que bueno para su clase de español de matemáticas. Es muy importante. One second.